Welcome back. I have another project to share with you. It's related to MTConnect, that's Machine Tool Connect, which is an open source or royalty-free protocol. I guess there is no source. And I've implemented it on a S7-1200, and we've implemented what MTConnect would call the adapter portion. Let's dive into what we're going to cover. I'll give you just a 30,000-foot overview of the terminology used in MTConnect. I am not a MTConnect expert. I just dove into this for one of our customers. Our customer makes equipment that surrounds CNC-type tools. The company running the shop wanted to make data from these machines available. So these machines were developed using the S7-1200. They needed to be able to share data. That's the motivation for this project. I'll also share the software tools and resources I used to develop this library. And then I'll actually give you a demonstration of opening the library and adding 4 tags to a S7-1200, where we will connect it up to some I/O and some counters and send data across. First of all, the 30,000-foot view of MTConnect. We have at the top the client or the app, and each piece of equipment has an adapter, and that's what we're going to look at closely today. The agent is a data consolidator. All the data transactions in this scheme are human readable format. You can connect and simulate using the simple tool. Putty is what I use to start simulation and check the formation of the timestamps, things like that. First of all, there are a couple formats that are a part of this, but all of them are human readable, which was one of the design goals that they set out for MTConnect, that everything is simple and everything is human readable. No data compression. So agents are that middle piece that I showed. Those are the data consolidators of MTConnect. They take data which is pushed from the adapters, and they log it in a database and then make that data available to the apps or the clients. They make it available through a web HTTP format. Lastly, data sent from the adapters is sent in the SHDR format, which basically is just a timestamp, name value, or name and then a value, timestamp, then like an e-stop, and then a true or false. They have an alternative format where you can put more than one tag and value on a line. That's where they're like sampling XYZ from a machine tool, and they can put it all together with the same timestamp. Our application here is going to use the very, very simplest format, just timestamp, name, and value. There's other variants not covered here. They have another timestamp with more data values. But one of the things I learned when starting this is to make use of MTConnect, you don't have to implement every single feature. You can do just what you need to make agent and the apps happy. As long as we hit the right formats, everything should be good. And the other tenet of an adapter is the data is sent when there is a change in the data. So we're not streaming data periodically. The agent and the app then make up that time between data changes, and they can kind of fill in what a state of any particular tag was for a particular time range. So that does cut down on the data transfer where we're not transferring in the most compressed formats. So that's probably one good thing. The data from the adapter to the clients or the apps is sent, like I said, with a simple HTTP query. The query on this page is showing data from the SMS testbed that NIST has out there. So you can do any of these queries. You can form a query of like samples of data. And if you take a look at the query up here, sample count 50,000, you can then pull that into a spreadsheet, do a chart, whatever you'd like to do with that. I'm gonna just leave it at that for the agent and the apps. That's just how they function up there with the data that we're gonna collect. The data from the adapter is sent up with the format SHDR or shatter, and that's going to be that simple time date stamp. The date stamps are wrong here because the PLC, when I grabbed this, had the wrong date in it. But you can see that we're date and time stamped down to microseconds. Then we have a tag name, and then we have a value. You can send integer value, float value, and Boolean. The way I've implemented it, I only allow true and false. There's some other data types that they support in the protocol, but again, I've chosen to define a narrow format, at least for the first go around on this library. The other part that's included in the GitHub, there is a definition file of an XML definition for your machine that is needed by the agent. So that knows what data could be coming on the SHDR stream from your adapter. All of the tags that we implement in the 1200 PLC will need to be part of that XML file. And again, I included a sample one with the sample tags that I have loaded. One of the other tools I used to edit that XML file was XML Notepad from Microsoft. I just searched for XML Notepad 2007 download. That takes you right to that. It's a small file, allows you to edit all the tags cleanly with in the XML file. You can use your favorite there for sure. That XML file, if you're going to use the GitHub, MTConnect GitHub supplied Windows code, that XML file will end up in that directory, and I'll demo all of this. The agent can run as a service on your computer, or it can run in the command line. It uses that XML file, and then there's one other file you edit, a config file to point at the IP and the port number of your PLC. Okay. The GitHub for the code I'm going to show off is listed here. You can retrieve all of them or just a library. Right now, at the time of this video, I have V13, V14, and V15 out there. Sure, I'll put up a V15.1 when I get that loaded. It has 4 subroutines that are used to make the MTConnect adapter connection. And then we'll just walk through calling the MTConnect function block from your main organizational block. We'll create a time task for data collection. If we just put all the data collection in the main task, that would run, let's say your PLC is running at 10 15 millisecond, that would provide maybe more samples than you're after. Part of that XML file, there is a spec for the data collection speed. It's not going to affect anything. I just wanted to implement that part of the spec where you can control the number of samples sent for your data. So then we're going to test the connection using PuTTY, and then we'll test the connection using the supply MTConnect org's C++ implementation of an agent. And then we can actually look at live data coming across on one of the web pages that I showed earlier. So on to the demo. Okay, here we go with the demonstration. We're going to bring in a 1200 CPU. I'll just show off what we do, or at least what I do with every project. The first thing I'm going to do with this 1200 is make a few initial settings. And we'll need some of them, not all of them we'll need for this project, but first we always change the startup after power on to warm restart to run. Always a good practice if you don't like going back out in the field to restart a project. I always set the configuration time down to 6 seconds. That'll save you some time as you're downloading to projects that might not have all of the I/O connected yet. So that reduces that pause that you get right after a download. Okay, and the default is the correct setting for the center. And the next thing we're going to do is system in memory, clock memory. So for this project, we're going to need first scan, which is here with the system memory byte. And you can see it made my first scan tag right there. Just out of habit, I will turn on the system clocks. So that's the hardware config, and I think I will leave the IP address at 01. I think I could make that work for this demo. And next we're going to need to get a library brought in. What you'll do with that library that you received on GitHub is retrieve that library that you got from GitHub. Under Options, Global Libraries, Retrieve Library. That should grab that library and then import or open it up in the global libraries. So let me find that version. Okay, there's the archived library. Where is it going to put it? And then down here on the right, we see we have an MTConnect library. I will open up the programs folder, and we were going to drag one folder into that. And then we are also going to drag in 2 data types. And that should be it from the library. So first I'll drop the copy of program blocks onto the program blocks. That gives us this folder here with the four files in it. And what we need to support that is 2 data types. And we're going to drop those onto the data types. That's everything that comes from the library. We're done with the library at this point. Next, to implement it, we need to call the MTConnect function block out of main. So I will just drag the MTConnect function block 1 into main here, and we'll use a single instance. That's going to make a data block up here in the main program blocks, and that contains all of the instances of the functions used inside of MTConnect. We can go ahead and tag this up. So I will put that first scan on the first scan. Basically, that just forces it to initialize some of the COM port things on the first scan of the PLC. We'll leave 7878 as the default adapter port, and we'll leave connection 1. So you may need access to these. I have a tag here. I'm just going to use that memory 5.0. And if I rename that tag, we can call that connected for the program. And status, we can bring that out, MW. I'll just put it into memory word 6, and I'll rename that to MTC status. That can be helpful if you are unable to connect. That code can be looked up in the help for T receive _C, and there'll be codes like 809B or something like that, and that would help you potentially debug the reason that you can't gain access to the port, for example. Okay, so this runs in ad hoc mode, so there's no need to put any connection partner information in here. The error actually isn't implemented at this time. It may or may not be in the version that you end up downloading. With that, we should actually be able to download to the PLC and should be able to make a connection. We can go ahead and just test that, and then I'm going to show off a few features and hook up data. So we're compiling, and it should download right after. I'm just going to overwrite everything that was there. So I have to tell it CPU will stop, and everything's good. So at this point, it's going to restart the CPU, and we can monitor status here. We are ready for a connection. If we were to look this up, we'll say we're not connected, but we are ready for a connection. And we are not connected, so connected equals false. And we're ready to test. So I use PuTTY here. If I type in the IP of the PLC and the port number, again, the port number came from here, and we're going to just do a raw connect. Okay, when I do that, I have a trigger from when this goes to true to release a single instance of all the tags. So I mark all the tags as for sending, and I'll show you what I mean there, but you can see that we get timestamps and tags and status. So our two numerics are set to 0. F tag, floating tag 1 is set to 0, and E stop is a Boolean, and B tag 1 is a Boolean. And those are both false. We know that all of this part is ready to go, and we're ready to connect to an agent. More correctly, an agent is ready to connect to this adapter. But we do need to take a look at the tags. The MTC data is the holding structure, has the holding structures for the tags. Here's an expanded view of the MTC data. This is where you would change or add your tags to the system in your naming. I've supplied an XML device that matches up with these tags here, but you are certainly capable of editing these, and these are going to be the tags where you write the actual data from the PLC. If I have a Boolean that I need to transfer, I would write it to the value here and here. If I have a numeric that I need to send up, I send it to the value here and the value here. The tag names are ESTOP, BTAG1 that we talked about, cycles, and FTAG1, floating tag 1. You'll see that I've allowed up to 20 characters. That could also be editable. Everything that's open in this program would allow you to change those data types if needed. When we're dealing with the floating or the numeric, we have the ability to edit here the decimal places. So leaving that at 0 would, in essence, give you an integer data, and changing that to a number of decimals would give you, the number of decimals that you'd like. Keep in mind that these data types are allowed about 7 digits of significance. You can't have 1,000,005. There's just too many significant digits there. It'd round it off. It'd be 1 million. I'll show you more when we actually get to populating this data here. We could populate that data right here in main. I could add another rung here and just send data right into that empty data block, into that structure. I can show that here. So let's take a real world IO, I0.2, and let's rename that to the ESTOP coming into this machine. And then we will take that data, that Boolean, and put it into the structure for sending. MT data structure, Booleans, Boolean 0, and the value of that. So that will directly take that into the structure, and it will become available to the agent. I will just download that. And we can demonstrate when that data. So we're ready to send this real world IO out in SHDR format to the adapter. So we're going to use PuTTY to simulate the adapter here. Again, 192.168.0.1, port 7878, and a raw connect. When I connect, again, I tell it to send all data. So none of the data is changing, so that's the only 4 SHDR transfers that you see. So I'll go ahead and turn on that ESTOP, and you can see an extra data line here with the ESTOP and the true is transmitted. So again, we transmit data only when the data changes. I'm going to switch over to that data block, and I can show off a little bit more how this works. Here's our SHDR data, and if I were to just poke in a numeric value here, 1000.123, I've got a physical value of 100,123. When the previous value is set equal, that tells me that it was sent. And we have the decimal set at 0, so you'll see we got 1,000 only. So if I went to modify this, if I modify this decimal, let's say we want 3 decimal places, and in order to initiate a transfer again, I need to make a change in this value. We'll put in 1000.121. The previous value is made equal, triggering the send, and we now are sending 1000.121. That gives us the 3 decimal places. If we want to continue hooking up this data, I'm going to leave the adapter running. I am going to make this part a little bit more compliant with the spec. We want to collect data at a certain interval, or which you will define on your own, but we might not want it to come in if there's a fast data change. It could be changing, a value, a floating number or an integer could be changing scan to scan. And let's say your scan is 8 milliseconds and you don't want to flood the data channel. You can set all of these types of connections into your program into a time task. So we'll add a new block and we'll set up a cyclic interrupt, and we'll set it to set to 100 milliseconds. If you need to change that, let's set it up to 500 milliseconds. Go back into properties and we'll change that to 500 milliseconds. Okay. All of the data collection that I do here is going to be done only once every 500 milliseconds. And I'll take this rung here, I'll cut it out of the main, and I'm going to put it into this 500 millisecond task. We will continue connecting up data, so we'll probably have, let's say we have one more digital, so I 0.3, next physical input, we're going to rename that tag to, I believe it was B tag 1, which was the next tag, and that was Boolean. That'll be part of Boolean 1. Back in the MTC data file. So we're going to be writing that data to here. And let's do the numerics. So we're going to write cycles. Let's put that back to a digital or a integer number. And we're going to write cycles, like a cycle count there. And our other floating tag, we can modify that to have 2 decimal places. You would be doing this offline before downloading, so you need this to be permanent here, the start values, and you'll want your decimal places defined ahead of time. let's take every 500 milliseconds, this code will be executed. We can just add 1 to the cycles. So we'll add whatever MT whatever's in that numeric value 0. We're going to add 1 to it. And it's going to go back into MTC data numeric 0. Okay, this would more likely be a move command from some cycle counter that you had in your program. We're just simulating it so we can get data running on our application. Let's take and do something similar here for the next tag. Let's take MTC data 1 value. That's the one where we had a couple of decimal places. So data 1, we'll add 3.14159 to that, and that's going to be a real 1. Goes into numeric value 1. If we download this, we should have some actual data moving across. Looks like I have to do a stop. That canceled my connection. So I'm going to need to reconnect, and you can see that we've got data every 500 milliseconds, and we are counting up. I did lose the decimal places. I can do that on the fly, though. Let's put the decimal places here so we see 2. Modify that to 2 decimals. Again, you would have done that in the start value so that that would have been more of a permanent configuration. But if we go back here, you can see that we have, so we can see that cycles is set up as a integer type number, even though it's a floating point in the PLC. That's a point I should mention. But you can see that we're getting data in the format that we specified from the MTC data block. If I were to been, changing the digital inputs, that data will also been in that stream. That pretty much does it for the PLC side. The last part of this will be actually connecting up with MTConnect supplied agent, and we'll be able to view this data. So I'll have one last segment where we make that connection, and then we'll do an HTTP query off of that data. Okay, this is the last part of the demonstration. We're going to take that adapter that we made and connect it to internal data of the PLC, and we are going to connect it to the demonstration agent that's supplied by MTConnect. And I went ahead and installed that. It can either install and run as a service. You can see I have the MTConnect service here. I just started using this for testing where I can stop and start this here. But it works out of the agent directory, which is in program files, MTConnect. MTConnect agent is where it installed itself. It makes use of several files there. This is in the program files directory, so you'll have to use administrator privileges to overwrite here. I took the devices XML file that was originally there, and I renamed it old, and then I brought in the devices that I supplied on my GitHub. So with this, if I double click on it, it's going to bring up, since I installed that XML Notepad. Again, you can find that it's like the first Google for XML Notepad download. And that's directly from Microsoft, mostly trusted source. I'm not going to go deep into this. I took a XML file from one of the simulations, and I kind of pared it down, but I left some of the structure there in case you wanted to use it so that you didn't have to go back and remake it. If you'll remember, we were using like the e-stop. I just did a search to get down to that e-stop event. You can see it's a little bit down in the tree structure under devices, components, controller. That's one of the data items under controller. Some of the other ones, I added the btag1 that's in our demo. There's some others that were here already, and again, part of the protocol spec that we're not using. I used a sample here for the category and an event up here. Those two categories will accept pretty much whatever you send. There's another one called a condition where you need specific, like warning and fault. You need specific text strings in order to make those happy. And I'll leave it to IT people to figure out what type of log data they want, but you'll set that in here, you know, sample, event, condition, whatever it is. Again, I have not implemented a condition data type at this point. Those are the two Booleans, and if I find Control F, I'll look for the ftag1. That's down here under a rotary axis. I just added the cycles and the ftag, and those are both samples. Okay, so that's the file. Again, from the download, you'll need to move it into this directory, probably with privileges, administration privileges. You're going to need to also edit this agent.cfg file, and that will include your IP address for your PLC and the port number 7878 if it's default, a device type, devices, and again this should default, but this devices.xml is the file that you brought in from the GitHub download and you potentially edited using the XML notepad. So once that's correct, you can either do a command line or you can start the service. Once the service is started, it will create a log file and hopefully it connects up to your adapter. At this point, we can now do a query against that agent, and the service starts the agent on your loopback connector. So we can now do a query off of that server, and that'll be on your loopback 127.0.0.1 port 5000, and we will look at the current state of the variables. Here are a couple of our tags. There's the cycles from our PLC. We're at 3913. We also have ftag1, which is at 13,390. That's just been running since I've did the demonstration. Let's see if we can go back to the PLC. You can see that we have a connection from that agent. Maybe I can fix up that data type here again. So we'll put a couple of decimal places on the floating tag, and we'll go back. Now that everything's happy on this side, we can go back to the query that we made, and we'll see. Hopefully, let's update this query, and we can see that we have now 138,076.45. So we've got the decimal places there. Let's see if we can find the status of eStop. So there's the eStop. It's now false. If I go here and turn it on, you can see that we now have a true value in the eStop. So we're getting data from our PLC adapter. So I hope you enjoyed this project. If you can make use of this, great. It's up on GitHub, and you need to contact me. You can contact me through GitHub. I see that it will give you my email address. Okay, that'll do it for this video. This was a interesting project, and again, there was very little information up on YouTube. Okay, that'll do it for this video. Hopefully you found something interesting in there that you can use if you're developing your own. If you need to contact me, you can leave a comment below, or you should be able to email me through the GitHub website. Hopefully the links will be down below. The future of this project will definitely vary depending on the interest in it. With that, thanks for watching.